Good evening. If you want to learn about bird sounds, you're in the right place. I am Dennis Arndt, the program coordinator for Costa Cascades Bird Alliance. This evening, we are excited to bring to you a special program. But before I introduce tonight's speaker, I want to tell you a little bit about our regular monthly meeting at the Campbell Center. In exactly 2 weeks from tonight, we will feature Forrest Tomlinson. Last year, Forrest shared his adventures in Colombia. His videos, sound recordings, great photos, stories were top quality. On October 28th, Forrest will take us along on his trip to the far southwest of the Pacific Ocean, from Tasmania to New Caledonia. This promises to be another wonderful evening of extraordinary images and sounds. So mark your calendars for October 28th, Tuesday at the Campbell Center. Well, tonight, I'm happy to bring to you our guest from the east side of the Cascades in the state of Washington, David Lukas. David Lukas is a well-known naturalist, and he's an author based on the east side of the Cascades in Washington in the Methow Valley. He's written 7 books, and he has contributed chapters to another 40 books on a tremendous range of nature topics. He's led thousands of nature history tours, classes, workshops, and presentations. His most recent project is producing a weekly nature newsletter, and the link to that newsletter is available at the Coast to Cascades Bird Alliance website. So go there to take a look at his weekly newsletter. Before we get started, I want to give you a couple of things that I'd like you to make sure that you have yourself muted so we don't have any dog barks in the back and things like that. Also, if you have questions, you can type them into the chat bar and we'll probably get to them at the end, but we're not sure. We're going to hold questions to the end and we'll look at them in the chat bar and kind of see how that all works. So don't worry about that. So we're ready to get started. I want to tell you that I know David because he is a friend of Charlie Quinn's through the Nature Conservancy. And I did, even though I'm sure that Charlie Quinn's recommendations would be just fabulous, I did some research. I read some of David's writings. I watched the video of David talking about bird sounds. And I want you to know that I think he explains bird vocalizations better than anyone I ever heard before. So you're in for a treat tonight. So let's give, however you give a warm welcome over Zoom to our guest tonight, David Lukas. Yay!
Hey. Thank you. Thank you, Dennis. Oh, yeah, there you go. See the little claps going up. Thank you so much, everyone. What a pleasure to be here tonight. And thank you to this fabulous crew of folks that organized it and made all this happen for us. I am thrilled to be here on this early winter night, I guess we'll call it. It's already getting down into the 20s where I live. So let me go ahead and do a proper introduction when I do a screen share. So let me do the screen share and make sure this is going to work for us first. And then I'll use that as a way to introduce myself. So just to confirm, can you see that okay, Dennis and Debbie? Thumbs up?
Yes, yes.
Okay, good. Okay. So thank you, Dennis. That was a fabulous introduction. I really appreciate that. So just by way of introduction for myself, I have spent my life as a freelance naturalist. I started memorizing field guides when I was 5 years old, and my gosh, I've gone and done that my entire life, just studying field guides every single day. And I'm up until midnight every night studying field guides, studying field guides. And I go out into the natural world, I take observations, I come up with questions, I come home and I research things in my library and now on the internet as well. And then I put together what I've learned and insights I've gained into books and classes and presentations like this. I love to share natural history stories with people, love to share natural history information. And as Dennis mentioned in my most recent project is a weekly nature newsletter. I put the link in the chat also, and it's here on the screen. Please check that out. I don't make much money as a naturalist, so trying to do the newsletter is how I try to make a living right now. So please check it out. I think you'll really enjoy the topics I cover every week. Dennis mentioned some of my books. I don't want to like promote myself too much, but one book is Sierra Nevada Birds. I did this little pocket compact guide with life history stories of all the birds of the Sierra Nevada. I did a book for Lonely Planet, and I offer these as a thank you for people that sign up for my newsletter too, for paid subscription. This is a guide to the top 200 wildlife spectacles in the world, arranged week by week for the best time to go see them. And then I spent 4 years writing a book on how to create new words for speaking of the natural world, language making nature, kind of my passion project here. So enough about that. Tonight we are going to talk about bird songs, and what a cool topic this is. Seems like kind of a weird time of year to talk about bird songs because we're not really hearing birds singing right now. So just keep in mind that tonight's talk is about the whole bunch of bird vocalizations, including songs and calls and other vocalizations that birds make. There's a whole bag of bird vocalizations that we're trying to understand and we appreciate when we watch birds. So I'm going to be speaking about all of these, and I'm probably going to say bird songs a lot, but just understand that I'm talking about all bird vocalizations because there's really, as you'll understand later, there's not much difference between calls and songs and other vocalizations. So it's better just to put them all together. But I don't want to say bird vocalizations 100 times in this talk. So I might just say bird calls or bird songs. Just know I'm talking about all the vocalizations that we're trying to appreciate. Um, this song or this presentation is a little complex because we have a couple sound clips. So I hope someone will let me know if the sounds aren't coming across clearly. But I just want to start by saying that it's fascinating to me that the study of bird songs extends back to the beginning of human culture. And we know this because the earliest known musical instrument ever found is a 42,000-year-old flute made out of bird bone. And it indicates that 42,000 years ago, before there was any kind of written language or sense of what people were thinking about, you get a sense that people were already connecting birds in the beginning of human arts and culture and song. And then when you have the earliest writings, let's see, change this to my pen. You have the earliest writings. For example, I love this quote from first century BC. That's way back, and already they were writing about birds inspiring people. Thus, birds instructed man and taught him songs before his art began. In the first century BC, already people were making this connection. And there have been just countless poets and philosophers and musicians grappling with birdsong in different ways. There's been classical music scores, Beethoven, for example, and others. The philosopher Immanuel Kant made an interesting point in his book, The Critique of Judgment. And he wonders why we would never get tired of hearing a bird singing in our backyard, singing a simple melody. So you might have a bird in your backyard singing just a couple of notes every day, and you're like, oh, that's so beautiful. I love hearing this. Wake up hearing this beautiful bird singing in my yard. But if someone was in your backyard playing the same three notes on a flute, you'd go out and strangle them. So he makes the point that there's something different about birdsong. It's not just the musical notes. There's something sublime and wild and irregular about birdsong that takes us beyond our human arts. And I think it's worth keeping that in mind as we go through this talk. There have been countless poets that have worked tirelessly to capture the music and the cadences of birdsong in their poetry. They're playing with the rhythms and the sounds that they hear in bird songs to have their own poems sing like birds. So I just pulled out one example by Walt Whitman. The famous poet Walt Whitman got some advice from a well-known naturalist named John Burroughs, who suggested that Walt Whitman base his poetry on mockingbirds. So if you look at Whitman's poetry, that's exactly what he's doing. So I love this stanza here, for example. Soothe, 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 but my love soothes not me, not me. Spot on mockingbird cadence, stanza after stanza through his poetry. And so while poets and writers are trying to do that with their words, well, musicians are trying to do that with their music to capture the nuances of bird songs. I mentioned classical music scores, but there have been so many different ways that musicians have tried to mirror, imitate, replicate what birds are doing. And in 1921, this fellow, F. Schuler Matthews, wrote a book where he tried to put all the bird songs in North America into musical notation. And I want to play one little score. This is a piano score of what a wood thrush sounds like. So I will play just a little snippet of what a wood thrush is, and then I'm going to play the actual bird song itself and have you sort of see if it works for you. So here's the piano score. This is our first sound clip, so let's make sure this works. Okay, now I'm going to play a fragment of the same bird song and see if you think that this works. Oops. Let's see, go. Sorry, I had to click the right button. And so I think that it kind of breaks apart upon inspection. It doesn't, the musical notation doesn't quite work. But keep in mind that before the advent of modern recording equipment, this would have been the only way to capture and convey what a bird song was like. Well, all of this changed after in World War II when a machine called a sonograph was invented. And for the first time, we have a machine that gives us visual images of sound as they occur. Essentially, the sonograph is letting our eyes hear for us because we're seeing the shape of sound as it's created. There's two components. There's an oscillogram, which measures loudness. So the horizontal axis is time. So we have 1 second, 2 seconds, 3 seconds, and then the vertical axis is loudness. So what this one is showing us is the sound starts as 0, it ramps up to the peak, then drops down to silence, is silent, then ramps up to the peak, is loud, drops back down again. Not very interesting. So we're not going to work with the oscillogram tonight. We're going to focus on the sonogram. So the sonogram is fascinating because this is giving us a picture of sound in terms of frequency, which is the rate at which sound waves are produced in cycles per second. So again, this is time. And then in this case, this is cycles per second in thousands of cycles per second. So the bird song starts off at 5, which is about 5,000 cycles per second, pauses 5,000 cycles a second, and then drops down to about 3,500 cycles per second. Okay. So this concept of cycles per second is a little complicated to understand. So let's use a drum head as an example of what's going on here. So imagine striking a drum head with a drumstick, one strike, and we hear that sound. What is going on? When the drumstick hits the drum head bounces down and creates kind of a vacuum of air molecules. Then the membrane bounces up and pushes air molecules and creates a dense pulse of air molecules. Then it bounces down, creates another vacuum. And this cycle of one empty space and one condensed space is one cycle. And thousands of these pulses per second are hitting our ear, and that's the sound we hear. The tighter the drum head or the smaller the drum head, the faster it vibrates and the higher pitch it's gonna be. And if the membrane is bigger or looser, the membrane bounces slower and it's a lower pitch because it's a lower number of cycles per second reaching our ear. So in this presentation, we're going to use a lot of these sonograms. So I wanted to show you how they're created and kind of give you a little background on them. In the presentation, the sonograms that I'm going to use are static images because it's too hard to animate each one. But I'm going to do an animated demonstration here. I'm using a software called Raven Light software. This is a free software from the Cornell Laboratory of Ornithology. You can just go to their website, download it onto your computer. You can play any sound through it. Tonight, we're going to focus on bird songs, and it's going to give you these incredible images showing you what the sound looks like. And look around the edges at all of these ways you can play with it and measure and analyze and understand the sound that you're hearing. So what's going to happen is I'll hit play. A green bar is going to go across, and as it hits each part of the image, it will play the sound underneath the green bar. Okay. And then I love playing with the controls. So like half speed, listen to half speed. Now that is so cool. And that's a great way to learn how to to learn bird songs. Like when you slow it down and look at the pictures, all of a sudden it's a lot easier to learn them and to understand the bird songs you're hearing, rather than just listening to CDs or DVDs or something. These sonograms are an incredible tool for people that are bird watchers that love learning about birdsong, and they're incredible tools for scientists. This is a great way for scientists to understand the nuances of birdsong. So, for example, we have this picture of this bird song. You could have the next door neighbor and have its song and look at it and analyze it and look at the milliseconds and different frequencies and amplitudes and all those factors in it. You could have the same bird returning year after year and look how its song changes. You could have a bird from Eugene versus a bird from Portland and look how their songs are different. This is an incredibly powerful tool for scientists. And it's what we're going to focus on in the talk today is these sonograms. So humans make our sounds in our voice box, our Adam's apple right here in our throats. Well, birds make their sounds in the center of the chest in an area called the syrinx. And the sound that's created here in the syrinx in the center is modified as it comes up the windpipe, through the mouth, past the tongue and the beak, and out into the world. The sound that we hear is different than what's produced down below. And to find the syrinx, when you do a bird dissection, you have to dig down deep inside the body. You have to move aside bones and muscles and organs in order to find it. And it's located right here where the trachea or the windpipe comes down and it divides, and bronchi go to each lung. And this junction right here is where the syrinx is located. It's a very distinctive structure. And when you look at it in isolation, it's really an obvious structure because it has these cartilage rings around the trachea and then half cartilage rings around the bronchi. Well, these cartilage rings give it structural support so that as the bird is fighting and flying and moving, it's not bending and shifting the shape of the windpipe and changing its vocalizations. The shape is rigid so that the song is consistent no matter how the bird is moving in space. So we have cartilage rings here around it, and in cross section, it's these black circles. And then connecting to each cartilage ring is a muscle. And when a bird exhales, the muscles pull the cartilage rings with different tensions. And guess what happens? Between each cartilage ring is a drum head, drum head, drum head. It's hard for me to draw these here, but between every single cartilage ring, the membrane is stretched. That tiny little membrane is stretched tighter and looser. And the combination of all of those little drum heads added up creates that beautiful bird sound that we hear, the song, the calls, the vocalizations. We also have songbirds. They have extra muscles and they have an extra piece of cartilage here in the center called the pecillus, which gives them even more control of their vocalizations. So if we look at the birds of the world, there are 31 orders of birds in the world. 30 orders of birds are not songbirds. They have a very simple syrinx and they are born with their song. So guess what happens when you take an egg from a bird that's not a songbird and raised it in isolation? Well, they're born with their song, so that little chick sings a perfect song because it's born with its song. One order of birds is the songbirds, and they have a very complex syrinx, and they learn their song. So if you take one of their eggs and raise it in isolation, guess what that chick says when it grows up? It just sings gobbledygook because it needs to hear its parent song, adult song, in order to learn what it's supposed to say. So if we look at a field guide, just a standard field guides are organized so that the front of the book is the most primitive birds. And as you go through the book, it's evolutionary order until you get to the most advanced birds at the back of the book. And when you look at the field guide and go right to the middle to flycatchers, this is the dividing line. The first half of the book here is 30 orders of birds. And then the last half of the book is songbirds. So what does that mean? That means as birds were evolving from the most simple to the most primitive, at one point they developed complex song, and half of the birds in the world evolved very, very quickly because song is so important to songbirds. Oh, and here's something really cool too. There are 5 groups of animals in the world that learn songs. Okay. Songbirds are one. What are the other 4? So if we were in an audience, I'd be asking you to chime in, but I'll just tell you. So we have humans learn our vocalizations, our songs, and many of the primates, if not all the primates. We have whales and dolphins, porpoises, and we have elephants and we have bats. Those are the 5 groups of animals in the world that learn songs. It's a very specialized behavior, a very specialized group of animals that songbirds are part of. So not only do the songbirds have beautiful, complex songs, but a number of them have 2 syrinxes that they control independently. They essentially have the ability to duet with themselves. They can choose to use the left syrinx, the right syrinx, or both at the same time with very different effects. And thrushes are a classic example of a bird that has 2 independent syrinxes. So we already heard the wood thrush. So here's the sonogram of a wood thrush song. And what I did is I drew a brown box around what each syrinx is creating. So see how there's 2 boxes stacked on top of each other? This bird is singing 2 songs stacked on top of each other. And because of that, they're creating all the unique harmonics and nuances that make it such a beautiful, haunting song. So I'm going to play this and listen to this. That's beautiful, right? But it's pretty fast. So again, I want to play it at half speed. Now listen to this. This is incredible at half speed because then you really begin to understand what's going on. I mean, I think that's so cool. So that is 2 songs stacked on top of each other, creating all kinds of harmonics and resonances. I'll play that again because I think that is so amazing. No wonder we love birds. So it's classically defined, a song is going to be a bird's most musical and elaborate vocalization, and a call is just its simpler vocalizations. We have all been taught that songs are used for courtship, but this is not necessarily true. And it's surprising that scientists have never been able to define what a bird song is, and there's no proof that a bird song's purpose is to attract females. So, for example, there are birds there all day long. Some birds use their simplest vocalizations when they're on territories. They're attracting mates. They're defending territories. They're fighting with other males. They're using their call notes all day long. Then at the end of the day, the sun is going down. Females are on the nest with eggs and babies. Everything's quieting down in the world. The males line up shoulder to shoulder on branches and sing their hearts out like a glee club. It has nothing to do with territory. It has nothing to do with courtship. It's a totally different behavior that doesn't fit into an easy categorization. And there are about 10,000 species of birds in the world. and each one is kind of doing something different, that makes it almost impossible. Well, it has been impossible to say this is what a bird song is, this is what a bird call is, because there's 10,000 different versions of what's going on. So again, that's why we're talking about bird vocalizations, not just song, not just call, kind of using them interchangeably. So I want to impress upon you a really important idea that's going to be important for the entire presentation. So we're all bird watchers. Imagine that we're out for a bird walk. We're all walking along and talking and looking around. We go underneath a tree and a bird sings. So what do we all do as bird watchers? Whip up our binoculars. Whoa! Oh, there it is. There's a yellow-rumped warbler. Oh, that's so beautiful, right? Well, that's exactly what a predator would do. No binoculars, but as soon as you vocalize, you reveal your presence and you give away your location and you risk your life. So that means that every time a bird vocalizes, it is saying something so important to it that it's willing to risk its life to say that. So what might a bird say when it vocalizes? Well, obviously, it wants to say something about what species it is. Hey, I'm a American goldfinch. Hey, I'm an American robin. You want to say what species you are. You want to say something about what location you belong to. So, for instance, the Buick's Wrens of Eugene are going to sing different songs than the Buick's Wrens of Portland. And if you're singing the wrong song for your location, then other males aren't going to let you live there. Females aren't going to mate with you. You don't fit. So you have to signal that you are in the place where you belong. You want to express your reproductive conditions. So if you're going to risk your life to announce yourself, are you going to go, woohoo, ladies, I'll be available to breed next week? No, you're going to say, hello, ladies, I'm ready to breed now, an indication of your reproductive condition. So does distance away matter if you're another male? Well, probably yes, because you're a competitor if you're too close. So distance matters to males. Does distance matter to a female? Not really, because a female can fly closer to respond to you, or she can fly away if she doesn't like you. Whereas males are situated on territories, they have to stay in a small area. Females can move around. So distance doesn't matter to females. It's an important indication for males. So the amount of song indicates the health of a male because a healthy male has the best territory. And by definition, the best territory is rich in food. And the more food you have, the more energy you're going to have more quickly, and it gives you more time to sing. They've done experiments where they've given males supplemental food. Those males sing more often. They track the first females of the season. They have more eggs. They have better nesting success. The females that mate with the males that sing more have larger batches, greater health of babies, etc. So that's all an indication of your health because you have the highest quality territories. But there's other parts of your health that impact your song too. So for example, if you have parasites or disease, that's going to impact the quality of your song. If you have a stronger immune system, you're going to have more complex vocalizations. If you've had stressful events while you were growing up, that's going to get imprinted on your song for the rest of your life. And females can definitely detect all of those aspects. So I also put mood in here. So doesn't it make sense that a male's mood or attitude is going to be reflected in his vocalizations? Is he a timid male? Is he a cocky male? Is he respectful of other males? Is he a take charge kind of guy? Well, if you were at a party with a bunch of guys talking in the side of the room, you could tell what kind of personalities they have by how they talk. So, of course, female birds can do that with the male birds too. This is pretty simple longevity. The longer you live, the more elaborate and more perfectly practiced your song will be. Basically, you're signaling, hey, I've lived a long life. I have great genes, and I'll pass those along to our babies. Come on over and mate with me. And this last one is really important, so we're going to talk about it more. But basically, you want to show that you're part of the local gang by being able to sing the song that all the males in the neighborhood share. It's kind of like when you go to a high school football game and everyone sings the club song or something. You want to signal that you belong to the group. But in general, when you look at all of these different things that you're saying, the singer's goal is to manipulate the behavior of other birds, And at the same time, they're trying to manipulate him. And over time, this system of strategy and counter strategy has led to a communication system that encodes an extraordinary amount of information. And any bird that listens closely is going to succeed and survive. And this creates generations of super singers and super listeners. So birds have many types of vocalizations. So for example, common chickadee. We all have chickadees in our backyards. We're familiar with those. A chickadee has about 14 common types of vocalizations, and song is just one of them. So we're going to look at three kinds of chickadee vocalizations just to give you a sense of the diversity. But realize that we'll look at three, but there's 11 more. There's a lot. So for instance, there's the common chickadee call that you hear, especially in winter groups and around bird feeders, and if they're mildly alarmed. There's four components to this: A, B, C, and D. In this case, it's A, B, D, 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 D. Chickadee, D, 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 right? And the number of D notes can be varied to convey hundreds of different messages. So, for example, in one study this woman did, she discovered that two D notes meant watch out, there's a red-tailed hawk, chickadee-dee, chickadee-dee. If they had four D notes, it meant watch out, there's a pygmy owl, chickadee-dee-dee-dee-dee, chickadee-dee-dee-dee-dee. I think that's four. Um, and each flock of chickadees has its own unique chickadee call. And if a new bird joins the flock, it has to change its call to match the flock in order to belong to the flock. So we're all familiar with that. Then there's the gargle call. These are complex sounds that males use in aggressive interactions at close range with each other. Each population has about 24 gargle notes that they can choose from, and each male picks from that pool of about 24 notes a couple of notes that he puts together into his signature vocalization. Basically, what they're doing is saying, hey, I'm Joe. Hey, I'm Steve. It's their unique identifier. And then there's the hey, sweetie. Some people say cheeseburger, which is probably the chickadee song because males give it from a perch in the spring as if they're proclaiming a territory or trying to attract females. And one other thing this example call shows, which is really interesting, is that birds also do what are called song shifts. So if you're singing all day long, you don't want to wear out your vocal cords, you don't want to wear out your muscles or your nerves, you don't want to bore your listeners. So you vary your song as much as you can. Even in a very simple vocalization or song like this, they're doing song shifts. So listen for this. It's going to go, hey, sweetie, hey, sweetie, hey, sweetie, hey, sweetie. Listen for that. Hear that? It's subtle. So you can see there's lots of different kinds of vocalizations. We looked at three, but there's many more. But tonight we're going to focus on song. But even in song, each male has different variations of his song, and each one of those variations is called a song type. And all of the song types that a male sings is his repertoire. Okay. So we'll take the towhee. This is an eastern towhee. Same thing for spotted towhee. We'll use this as an example. So each towhee has 3 to 8 different songs that it sings. These are different song types, and its repertoire is going to be 3 to 8 different songs. Its strategy is it sings each song about 30 times in a row. Then it goes to the next song in its repertoire, sings that about 30 times in a row, then goes to the next song and sings that about 30 times in a row. If that's the end of its repertoire, it goes back to the beginning, or else it keeps going through its repertoire until it gets to the end. So, if you listen closely, you can start to hear these, but think about how we listen to birds when we go on a bird walk. So, we're out walking along again. We're a bird watching group. We're out walking along, looking around for birds, and what a towhee pops up. Oh my gosh, up comes our binoculars. We're looking at this bird as he's singing. Oh, it's so beautiful. Look at those red eyes. Look at that red on his side. What a gorgeous bird. We whip out our field guide. We flip through it. Towhee, check. And then what do? We close the book and we keep walking. And what has that bird been doing that whole time? Well, he's probably been singing one song type the 30 times, and we think that that's what a song is. But if we were to stop and sit down and start to and just eat lunch and start to pay attention, we could start hearing it go through its repertoire. So here's an example of that. I'm going to play three song types, each one twice. So listen to this and see if you can hear this. There's the first one. Here's the second one. And here's the third one. Could you hear that? Oh, oops. So I'll play these again with the sonograms. And again, you can see the value of having a sonogram because it gives you a picture of what you're hearing and why it's different. So same thing. Oops. Can you see that and hear that now? Here's another example. I mean, we can do this for any bird practically, or any of the songbirds at least. Um, so red-winged blackbirds, we're all familiar with red-winged blackbirds. They sit in marshes, conqueree, conqueree all day long. Again, each male has a repertoire, and in the case of red-winged blackbirds, they have 4 to 8 different songs in their repertoire. So again, here's two versions, two song types, each one twice. And then at least we think it's just males that are doing all the singing and having all the fun. Females vocalize a ton too. In fact, females in most cases can even sing. But what happens when you sing? You reveal your location, you risk your life. Females don't need to do that. Their job is to be hidden and usually to be hidden and feed the babies and take care of the babies. The male's the one who has to risk his life. He has to sing loudly. He has to perch out on the open. He has to chase other birds. He has to have these flashy colors. And in the case of red-winged blackbirds, they have this gorgeous red shoulder called an epaulet. And that male is like strutting around, showing that off. His job is to attract females and have a harem of females. He wants to attract as many females as possible. So he's strutting around, showing off, singing, "Hello, ladies, come on over and check out my harem. Come be part of my harem," right? And in the meantime, the female's got her hands on her hips and she's like, "Hello, buddy, get over here and help at the nest," right? So he is singing his beautiful song, and she comes over the top of him with a wall of sound and drowns out his message. So he's saying, "Hello, ladies, I'm," basically scolding him and drowning out his message. You can see how it disappears into this wall of noise. Um, so not all bird songs are unique and variable. So many species share calls that they all need to have in common. So for instance, every small bird in the neighborhood needs to know when there's a hawk hunting nearby. And so all the small birds use the same alarm call to announce the hawk's presence. And the reason for this is very simple. If other birds understand your call, you save them from being surprised by the hawk. And if you understand their call, they save you from being surprised by hawk. So imagine we are all a group of sparrows. We're all hopping around on the ground, eating seed, and I look up and I see a hawk screaming in at us. What do? "Watch out, everyone!" Wham! Guess who gets eaten by the hawk for announcing their location, right? So there's no incentive for me to announce the hawk is coming if I'm the one that's going to get eaten. So what happened is all the small birds have agreed on the same very high, very thin little note. Everyone can hear it, the hawk can hear it, but no one can pinpoint it. It's ventriloquial. And when all the small birds hear it, they freeze in place. No one moves. And the hawk can hear it, but it's looking around, can't see anything, gives up and leaves, right? So this is how they can all help each other out without risking their lives individually. So I'm going to play 3 versions of this, but just a heads up, this is very high and thin. And even sitting here at my computer, I can't really even hear it. So if you don't hear anything, um, you can try turning it up. But if you don't hear anything, my apologies. Just know that it's a very high, very thin call note. So likewise, an owl is also a threat to all the neighborhood small birds, but they're a different kind of threat. So what is an owl doing in the daytime? Well, an owl is sleeping. So is not a threat because it's not actively hunting. So all the small birds use a completely different kind of call called a mobbing call, and it brings all of the neighborhood birds in. Hey, everyone, there's an owl over here. Come on over, check it out. Let's get it. And all the small birds come in and they start harassing it and scolding it. And the poor owl is just like, leave me alone. And then usually flies away to get away from them. And look how different these calls are. These are not high, thin, impossible to pinpoint. These are broad spectrum walls of noise that are easy to hear and easy to pinpoint. So those are all ways of announcing where the owl is and having them come in. So another way that bird songs vary is regional dialects. So this starts out as subtle differences between different neighborhoods. Like I mentioned, Buick's Wrens in Portland are having different songs than the Buick's Wrens of Eugene. So you have regional variation or different neighborhoods singing different songs. And over time, this leads to new species because birds tend to breed and hang out with other birds that make the same vocalizations. So here's a diagram from a classic study with white-crowned sparrows. These birds love to live in brushy habitats, and in this study, this is chaparral, dense, dry chaparral habitat, which burns very, very hot. So there's one big population, all singing song type A. Huge fire comes in, burns this big area. No one can live there. There's no food, no plants. Over time, the vegetation starts to spring back up. A few hardy pioneers start to move in, and if they are successful, they establish little subpopulations. And because they're isolated from the parent population, they start singing different versions of the song. And as the population grows, each subpopulation grows, they stick together because birds like to hang out with and breed with birds that sound like themselves. And these little subpopulations get bigger, they expand until all of the lines meet up again. And all of a sudden, where we had one song type A, we now have A1, A2, and A3. We have four song types, and birds will never cross these lines. These lines can be 1 yard, 2, 3 yards going through the landscape, and birds on one side will never cross and breed. And right here, with one fire, you have the potential for four species. This is why there's so many songbirds in the world, because if every fire does with white-crowned sparrows, it's doing it with other birds, and over and over again, you get these divisions of dialects and populations. Here's a real-world example with marsh wren. What a cool bird, right? And the red here is their breeding range across northern North America. During the Ice Age, massive glaciers came down the Great Plains and cut the population in half. There's a West Coast population, East Coast population for tens of thousands of years, right? They developed different dialects. Then when the ice melted, they expanded and they now meet along this green line that goes down the Great Plains. This line goes right down through the middle of marshes. Birds on one side are singing one dialect, the birds on the other side are singing the other dialect. They never cross that line. They're basically two species now. So here's West Coast marsh wren versus East Coast marsh wren. So there's two main reasons why birds might sing, territories and to defend a territory and to attract a mate. And we tend to think of males singing to attract females as if males were the dominant focus of the entire social hierarchy. And this is probably because so many bird biologists have been male, so they think everything revolves around males. But there's a growing body of evidence now that the entire system of bird song and breeding behavior is controlled by females. So imagine it from the female's point of view. The male can sing his heart out all he wants, but he can't do anything about it. Females make all the choices and pick who they want to mate with or not mate with, um, based on their song. So it turns out that when a male is singing, he has two different choices and two different needs. And if you are defending a territory, You are right on the boundary facing off with another male. Hey, I'm Joe. This is my territory. Hey, I'm Steve. This is my territory, right? Well, you can't just sit there yelling at each other. You can't do that all breeding season long. And at the same time, there's a hawk up there going, woo, this is simple dinner, right? So you don't want to spend your whole breeding season at your territorial boundaries screaming at your neighboring male. So when it comes to defending territories, they have created a different kind of vocalization, which is a substitute for combat. That's really important. They don't want to fight each other, but the sound breaks down very quickly. So you can hear it when you're close up, but as soon as you start moving away, it just turns into background noise. So birds can use it to judge how close they are and whether someone is a threat to your territory. And we had that example with the gargle call, right? And this is a call that's meant to be heard close up. It signals that a bird is really close to your territory and is a threat. But if the bird is more than a few feet away and you get further away, it's just background noise and you don't even respond to it, right? There's two really important things about these kind of territorial calls. One is that it's unique to each male. Each male has his own unique version of it to announce who he is. And the other is that the sound doesn't carry very far. Okay, so imagine you're trying to attract a female. There's a female down here in Mexico. She's migrating north to Canada. She's 100 feet overhead. She's flying fast. And you're down here on the ground. Hey, I'm Joe. Is that going to work? No, that's not going to work. Does she, can she hear you? No, she can't hear you. And does she care if you're Joe? She doesn't care if you're Joe. So that is not going to work for attracting females. You want to go, yoo-hoo, ladies, I'm a male yellow-rumped warbler. Can she hear that? Yes, she can hear that. And she cares that you're a male of her species. Zoom, she comes right down and check you out. If she likes you, she'll stay and mate with you. Okay. So we heard this already with the chickadee song. These songs can travel a great distance. When you hear them in the forest, I am used to hearing them in the Sierra Nevada, and I think you can hear them a quarter mile away. They're very clear, piercing, and more importantly, they travel a great distance and they carry all the information a great distance. So remember all those different layers of what a song could say about a bird? All that information is being carried a great distance for um, females and other males to hear. Okay, I was going to mention the Dennis. We started a little bit late, so I'm getting close to the end here. Don't worry, I'm aware of the time, paying attention, but I want to get in these last couple slides here. So this is where it gets really fascinating, is that neighboring males share songs and they recognize each other. And this way, it's really apparent when a stranger shows up. So in this example with indigo buntings, I'm not going to play these. I'm just going to show you the sonograms. Look at the territory holder, look at his song, and then look at the sonogram of his neighbor. Do you think they'd recognize each other? Look at those songs. They're almost identical, right? They are matching each other's songs. They know each other. And when a stranger shows up, here's his song. He can't even pretend like he belongs because his song is so different. They immediately recognize that he's invading their neighborhood, their territories, and they need to respond to him. Okay. So not only do males know each other, but they know where they belong in the landscape. So this classic study they did with ovenbirds on the East Coast, they took three males next to each other, male one, two, and three. They removed male one and played his song through a loudspeaker on the border of male two. What does male two do? Well, probably nothing. He might sing back, but it doesn't matter. It's just male one singing on his territory. Then they played the song of male three through the same loudspeaker. And what does male two do? He goes bonkers. So why does he go bonkers? Does he know male three? Yes, of course he knows male three. He's his next door neighbor. But male three is in the wrong place now, right? So they agree on this boundary, but they've never talked about this boundary. So that requires some action. They need to like work out their differences. Time to get on board with getting excited. So they know each other and they know where they belong in the landscape. Here's a study with song sparrows, and these circles are four males with adjacent territories. The circles are not their territories, they are their repertoires. And each letter is a song type in their repertoire. So in the case of song sparrows, they have about 10 songs in their repertoire. In this case, bird one has A, N, B, E, F, H, J, K, and L, 9 songs. Bird two has O, P, I, D, B, E, F, H, A, J, K, L, 11 songs, so 10 on average. And what does this diagram show? It shows that adjacent males have overlap and they share songs. So in this case, these two males, let's see if that worked. Yep. Share one, two, three, four, five, six, 7 song types that they share. They have other songs out here that they don't share. They will never sing those to each other. They only will sing the songs they share to each other. And they have 2 choices. They can do what's called a type match. So if bird one sings type B, bird two would sing B back. That is a type match. It's highly aggressive. They do it early in the breeding season when they're working out differences with each other, but they can't do that all breeding season long. It's highly aggressive and it's a challenge. So they can do a repertoire match later in the season. So if bird one sings B, bird two doesn't sing B back, which would be a type match and highly aggressive. It's going to do E, F, H, J, K, or L, which is a repertoire match, which is a way of saying, hey, I'm singing one of the songs that we share. We know each other. We're next door neighbors. Don't worry about it. Right? So here's a real world example of this type matching. This type matching is so fascinating. So again, we have our marsh wrens, incredible birds. They have about 150 to 200 songs in their repertoire. All the males in one neighborhood share the same repertoire and have the same sequence. And a male can choose to skip ahead in the sequence or fall back or double up. Every single hour, a male has 600 choices per hour of what to say to each neighbor. That is a ton of information. So in this example, with this perfect type matching, oops, what did I do? They put a microphone out in the marsh. One bird is further away, so it's a little bit quieter. He calls first. The one that's closer to the microphone and louder replies. And no matter what the first bird sings, whatever type he sings, the second bird perfectly mirrors it. So listen to them. This is highly aggressive. They will do this for hours or days until one of them gives up. Oops. Let's see. Can you hear how they're just matching back and forth, back and forth, back and forth? Have you ever had, when you were growing up, did you have a sibling that repeated everything you said and how incredibly aggravating that was? This is exactly what's going on here. They are just going at it with each other. And again, they'll do it for hours or days until one of them just gives up and says, hey, you're the boss. That's your territory. I accept your boundary. So why do birds share songs? It seems that birds share songs for a very simple reason. If you share songs, it means that you are long-term neighbors, and long-term neighbors are going to be preferred over newcomers because newcomers are inherently expansionistic. They come in, they don't have territories, they need to kick and fight and push out of space to create a territory. Whereas old neighbors that have established hierarchies respect those boundaries once they're agreed upon. And this sharing of songs makes territory defense very efficient because you don't spend all your time fighting with birds you already know. You just establish boundaries and hierarchies, encode it in song, and then the rest of the season you can relax and just sing and listen to each other and understand that everything is in balance, right? And this is so important, and this is where it gets really cool. This is so important to these birds that they actively teach young birds their songs. So in this study, this is the song sparrows again. Look at these boldface letters. This is what happened in this study when a young male who was just wandering around showed up. Well, a young male's not a threat because he's not ready to have a territory yet. He doesn't know how to be an adult. He's just wandering around. But these old timers that already have their territories sit him down and teach him their songs. And each bolded letter is the song type that they taught him. And look where these bolded letters are. They're in all of the overlap zones, right? And there's one here, it's probably with another male out here. There's one here, it's probably with another male here. They are teaching him their overlap songs, which is a way of making him part of the neighborhood, right? And then over the course of the first winter, the chances of one of these old guys dying is pretty high. They don't live that long. And if not, the next spring, this young guy is the hot new stud. He can kick one of the old guys off the territory, but he already fits because he's already learned the neighborhood shared songs. He goes right into the spot. He fits already. Um, I just think that is so incredible. Okay, so let's go ahead and wrap this up because we are right around the time. So, in summary, remember some of the things we've learned. Each species has its own unique vocalizations. We all know that. Each region has its own dialect. Each neighborhood has its set of songs that all the males are going to share. And then each male has its own voice and its own repertoire of its favorite songs. That's a lot of layers of stacked layers of information. There's a lot going on here. It's so incredible. Um, and remember the idea I mentioned earlier that birds take a big chance when they sing. So they obviously, every time they sing and risk their life, they have something important to say. And we are just beginning to learn what some of these messages might be. We learn that birds have many kinds of vocalizations and many variations, and each one of them has a different function. But they seem to fall into two main categories: to either defend territory by communicating with other males or to attract females, mates by communicating with females. And what I think is so fascinating is that we can hear all of these vocal strategies going on in your backyard. Um, and we've come such a long way in understanding how bird songs work, especially with these sonograms, which give us such an insight into the really subtle differences between different bird vocalizations. But I want to leave you with two really important thoughts. So now, even though we have the ability to measure the frequency and volume and minute differences between different vocalizations, we still have no idea or very little idea what birds actually hear or what matters to them. And finally, it's extraordinary that there's only a handful of species in the world whose vocalizations are fully known and understood. Remember the example of the chickadee? I said chickadees have 14 vocalizations. Well, how do we know that? We know that because someone spent thousands of hours listening to and recording all of the vocalizations that chickadees make and discovering that they fall into 14 categories. That's a ton of work. That's like a PhD level work. And there's 10,000 species of birds in the world, and that work has only been done on a couple of birds, a handful of birds. And what this means is that the full range of vocalizations made by almost any species you could pick in your backyard, your neighborhood park, has been little studied, and almost anything you could record would be new to science. And that's so cool. You could go out with a microphone, play with this Raven Light software, and what you discover is going to be a new contribution. And I think that's so amazing. So I'm going to end with that idea and see if there's any questions. And Dennis, if you were going to talk, you need to
Oh, there
unmute.
we go. I was trying to unmute myself. Yes,
Okay.
I have a question. Um, there are some species where it seems like the male and female are singing
Yeah.
songs.
Mhm.
Uh, how does that work and why does that happen? And what are some of those species?
Oh, what are some of those species?
Thinking of
What
finches myself,
you have pitches?
Gulfstream, purple finch.
Yeah, well, um, I think the main point I would make is that this is a very general picture of the world of bird vocalizations and bird songs. So with 10,000 different permutations on this, I mean, there's so much to talk about and learn from this. It's hard for me to generalize and summarize, but there are many species where females vocalize just as much as males. I'd say more in the birds that aren't songbirds. In songbirds, usually the males have some sort of elaborate, nuanced song, and the female might have sing, but it might be a simpler song. It's not going to have the complexity of what the male's doing. But there's lots of other vocalizations that both males and females can do as they chat with each other and interact with each other. But that might be different than songs.
I
Um,
just saw it as a chat here a question about does artificial intelligence show any promise for analyzing
oh
and
my God.
isolating bird calls?
Oh yeah, it would.
It
But
would, I suppose, sure.
yeah, I have no idea. I have not read a single thing about people using that yet, but obviously it's going to be happening, especially with a place like Cornell Laboratory of Ornithology that specializes in studying bird vocalizations. There's got to be people that are jumping all over this right now. You could feed endless numbers of recordings into artificial intelligence and have it analyze it and tell us more about what's going on. I just haven't heard of that yet. Great question, though.
Yeah, I have been collecting bird songs. I've been having fun recording them, and I probably have more than 12 different spotted towhee songs. I mean, and they're so different. It's just
Yep.
amazing to me
Absolutely.
how they can do
I
that.
think spotted towies are they're incredible. There's something going on with spotted towies. I mean, I hear them so many different songs all over the Western United States. They're doing something totally different, and someone needs to study spotted towies. God, they're doing something really unique.
Oh, maybe I'll do that in my next
There you
life.
go.
Well, I don't see any other
Well,
questions.
let me I
Oh,
forgot. Oh,
there's one
There,
about crows mobbing hawks. And crows, I get the impression crows are constantly communicating with each other,
yeah.
and they're having a great time.
Yes. Oh God, yes. You have to read like Bern Heinrich's, what's this called? The book about the raven, Mind of the Raven.
Yeah.
It's different than crows, but I have like six books on my shelf about the behavioral social systems of crows and ravens. Um, I have to admit I haven't read them yet, but uh, yes, they're always vocalizing. They have a lot of very complex messages that they're signaling with each other. I don't know that many people that are studying them yet, but yeah.
Okay. And were
Um,
you going to say something?
Yeah, I mean, I was going to say this at the beginning. I totally forgot. I was going to just mention some of the books that I would recommend on this topic. And I would also say a lot of the illustrations and ideas for this talk came out of this incredible book from Cornell, The Handbook of Bird Biology, this huge book. But this is like a great resource for anyone who wants to understand bird biology or does any teaching about birds. This is very easy to read, just jam-packed with information. This is an incredible resource. So highly recommend this. And as you can see from this talk, a number of the diagrams are excellent. Um, and then a couple of books that I think that have really influenced me. One is a lot of the information from this talk came from this fellow, Donald Kreutzma, who's
Mhm.
absolutely passionate about birds. Oh my God, this is a story of him learning about birds, songs. This guy is just like a dynamo. He's so incredible. This is just such a fun read because he's got so much energy and life energy, and his this uncovering the mystery of bird songs. So highly recommend Donald's book. A couple other books, What the Robin Knows by John Young about the how to understand what birds are saying to each other. Also a great book. And then Why Birds Sing by David Rothenberg, who's a musician and a philosopher, asking the question, why do birds sing? And this is a great book too. So wanted to just throw this out there because I always forget. And it's just so many cool books to share with people.
Well,
Yeah,
that's really great. Really appreciate all of that, and you did a great job.
thank you.
I
Thank you,
found it
everyone.
just really fascinating. Yeah,
Thank you,
so
everyone.
much
Yes.
more about vocalizations than we
Yeah.
normally would think about. Yeah.
Yeah. Thank you, everyone. And please check out my newsletter. I love to be connected to people. I love to share stories. I mean, we all do this because we love the natural world. And, I want to connect with people. I'm here as a resource. If people have questions, reach out anytime. I'd love to hear what you're seeing, what you're wondering about. Love to chat. So stay in touch, anyone. Happy to be part of this conversation.
Well, I see amazing things happening on my screen here. I don't know what all that is. I
That's
don't know how you do
technology.
that, but that's applause, I guess, and hearts and everything. Well, I think people liked your program, David.
Thank you, everyone, so much. It was a
absolutely.
pleasure.
Yeah,
It's so great to meet up this in the evening and all talk about
yeah.
birds together. Thank you, everyone. Good
Thank
night and stay in
you.
touch.
Okay,
Thank
thank
you.
you,
Bye.
Thank
everybody, and good
you.
night,
Thank you so
everybody.
much.
Bye bye.
Good night, everybody.
Good
Thank
night.
you.